first question is asking to choose from these. Now, of course, these drop-down boxes don't work on Google Slides, but this is something you may see on the Leap. So it says select from the drop-down boxes. The set of all points in a plane that are equidistant from a given point is called a, well, it could be either circle or sphere, but if you're looking, it says on a plane. A plane is 2D. A sphere is 3D. So the only option here is circle. And then this given point, if it's equidistant from that given point, that is the center of the circle. This question is asking, if you look at it, you immediately see there's an X on the side of a triangle, and we have to find what that side is. So it says, the figure shows that triangle ABC is similar, that means similar, to triangle DEF with side lengths as indicated. What is the value of X? So if it's similar, like we discussed last week, we know that we can set up proportions. If you look at the order of the way the angles are given in this statement, you can see what sides are similar to what side. So our first side is AB, and it is similar to DE. So we're going to make a fraction with that, AB over DE. And then we know we're looking for BC, so we have to go with BC here, is similar to EF. So BC is X, EF is 7. Don't switch those around. If you're doing the larger triangle on top in the first fraction, you have to do the larger triangle on top in the second fraction. Also, if we were looking for AC, we'd have to put AC there. So just be mindful of that. It can skip angles. It's going back to the first one. Okay, so now we have to do our multiplication. 7 times x is 7x. And then 21 times 7 is 147. And then we're going to divide by 7 here. And you get x equals 21. Here we have a proof, something that we don't talk a whole lot of after we've done it, but you will have proofs. You won't have to come up with the reasons yourself. They'll be there, a drop-down menu. So I want to give you a fighting chance here. So it says line CF intersects AD and EH at points BF respectively. That just means B is on AD, F is on EH. That's what respectively means. Okay, so it says, given that CBD, this angle, is congruent to BFE, this angle, prove that, ABF is congruent to BFE. Okay, so the first statement is CBD is congruent to BFE. So that's this angle and this angle. I'm sorry, CBD is congruent, that's this angle and this angle. Well, look up here, that's our given. So given will be here. So that's out. Sometimes there can be more than one given, and sometimes you can use things more than once. So don't just say, oh, I've already used that. Okay. Given is usually the first thing that you have. So please look back up to what was given. All right. Now we have to prove that CBD, this one here, let's go back to CBD is congruent to ABF. And what kind of angles are those? The first thing you want to do is, what kind of angles are those? Is that one of my options? So those are vertical angles. They make the X, or two V's stuck together. And there it is. So that would go here. And then it's saying, prove that ABF, which is, and we'll go with a different color, ABF is congruent to BFE now. So if these two angles are congruent and these two angles are congruent, then these two angles have to be congruent. So that is transitive property. You should immediately notice that this is the same as the one before it, but it's not asking to prove the same thing. So we got to put that out of our mind, what we just proved, and they may use different angles, they may use different degrees, whatever, but it's the same lines with transversal there. All right, so we're given that angle CBD is equal to angle BFE. Remember that little M in front of that means measurement of angle. And we need to prove that BFE plus DBF equals 180 degrees. So the first statement here is angle CBD is equal to BFE. Look and see if that's the given. In this case, it is the given. All right. Now we're proving that CBD, this one here, plus DBF, this one here, equals 180 degrees. Well, what kind of angles are those? Well, in the game we played, they were adjacent angles. Well, there's something about adjacent angles here. Angles that are adjacent are supplementary. Is that true? In this case, it is. In this case, it makes that line there 180, but not all adjacent angles are 180 degrees. So we can't use that one here. Supplementary means 180 degrees. Is there something else that shows 180 degrees? Well, look, here's something that says supplementary, and it's a linear pair. We don't talk about it a whole lot, but the key word here is linear. They make a line. Do those two angles make that line? Yes. So that would go here. All right. And then the last one says BFE, which is here, is congruent to DBF. Well, let's keep looking. It looks like, look what they gave us here. These two are congruent. And right here, these two are congruent, are equal. They're the same. So if I take this part out and put this part in, which I did, these two are the same. Okay, and I just took one out and put another one in that I knew was congruent with. I took this part out and put this part in right here. It's like when I'm absent, somebody comes and sits in my place. So the substitution property.